Right. So we were implementing Raft, right? Lab 3. Right. So we are on lab 3 right now. It's been a couple of days, so I don't really remember where I was, but let's see. So we have done this, and when they in Raft 1, when we do go test, so tests would be failing. I might have added some logs here, then some segmentation violation, nil pointer dereference. Perfect. Okay, we have done lab 1. You already have copy. Yeah. Cool. First we have to implement Raft by adding code to raft.go file. That is this one. We already have it open. Cool. I have added a couple lines of code. Let's see what it does. But yeah. Service calls make peers me to create a Raft PR. Enough time to write solid code. Okay, so we'll need to do this properly. Now part 3 is leader election moderate. uh, okay, let's focus on 3a first. Okay, it is giving a failure. And what's the test name? Can we see that? Fail. This is the test. This is the test. So it starts the go routine. Then we are doing condition dot wait. ah I remember this. Condition has to be something new condition, and then we need to pass some locker has to have lock or unlock variable, right? So what does wait do? Wait automatically unlocks the lock and suspends execution of the calling go routine. Cool. I really don't know what to do here, to be honest. So we'll see what the test 3a are, right? It first tests the initial election 3a, then re-election 3a, then many election 3a. Okay, leader election is what? Oh, nice. So we are focusing on leader election. First we'll fix the initial election 3a. Alright, this is also failing, which is okay. So I had added some logs earlier. We have peer 0, that's starting leader election go routine. Peer 2 was also starting this go routine. Then peer 2 started election. Peer 0 also started election. Peer 1 started the go routine. Everyone is just starting go routines. Who is going to vote for whom, right? That seems to be a problem. So let's check Raft. What all do we have so far? So we have Raft command type. It could be heartbeat or other. Raft command will be the type and data could be any for now. Each log entry has to have a term and a command, correct? There's something called log index also. If we take a look here, right? So this is our log index. You think of these inner values as terms. These are our log indexes. And yeah, cool. Then we have server state, or could say peer state, right? This is vim mode, but I don't know how to use it properly. So but we'll say uh, raft peer state. Cool. So in our raft we have a mutex, peer, some persister, dead or not. Huh, not important. So it asks us to use figure 2. So what does a raft server need to know? It needs to know its own current term so that it can vote or check the append entries once. uh, it can compare the commands it's getting the term. Then it needs to know who it voted for so that it does not do a second vote. Like a peer or a candidate cannot vote for two, uh, a follower cannot vote for two candidates. Then we keep log entry and then the current star peer state. Then commit index and last commit index is the last committed log entry starting at 0, and last applied, I guess it is the highest log entry applied to state machine. It doesn't have to be committed, I think. Commit means it has been applied to the KV store. Then leader knows next index and match index. This is basically for all the followers. And then just some last heartbeat, I'm keeping it at, so that no we can use it to maybe start a leader election. And then we implement this get state method that basically says the current term and whether it's a leader or not. Cool. Persist, we ah nice one. But yeah, it's not used right now. Persist is not part of the scope here. Then we have snapshot, also not part of. Okay, so request vote arcs, right? So this is the RPC arguments. If someone wants to request a vote, then they have to send their term, their ID, last log term and last log index. So like whoever is the peer receiving this request for vote will compare it with theirs, and if these are higher than their own term and index, then only they can vote for this guy. If a peer has higher term or index than the candidate, if a follower has higher term or index than candidate, then they will reject the vote and send their term, and this guy cannot become a leader. Then reply would be their term and whether they granted the vote or not. Now this is the request vote RPC. Append entries is for heartbeat, and we heartbeats are not saved to logs. Start command is there, then kill is there. This is simple linter related stuff. Atomic dot load. Then there's a ticker, I guess is internal to probably. Who's calling ticker? Ticker itself is calling ticker. Interesting. Then there's a lot of code here. Then there is a method for sending heartbeats. So yeah, leader is supposed to send heartbeats so that followers do not start those what do you say, leader election. And then we have this constructor, you could say. It gets a peer. That's all I think matters right now. So these are just start with current term, did not vote for anyone, empty logs, starting as follower, all these indexes are 0, nothing here also, next and match index. And okay, so it starts the leader election go routine. So everyone is printing this one, peer started leader election go routine. And till the time this peer is not killed, it runs in a loop, infinite loop could say, till the peer is alive, which makes sense here. Now we need to check whether leader election should be started. We are very defensive right now. uh, Basically, getting the lock whether it has already voted or not, then check its start, can it start election or not. So we are saying that if time since last heartbeat is greater than 500 millisecond and it's not leader and it has not already voted, then it can start election. And if it can start election, then it starts election. Good. So when you start election, you increment your term, you become a candidate, you vote for yourself, and you got a one vote. You need n by 2 plus 1 votes require, and pending votes is basically n minus 1 because you have got one vote. Now your last log term is 0. And oh, okay, what's the term of last log you have? Could be 0, but if you have some logs in your entry, then that's what you use. Then last log index, it's simply the length, current term, then you unlock it. You got this data, then you unlock it. Okay. And if you cannot start election, then we just unlock it. Now if you can start unlock election, then you iterate over all the peers, right? And if you are yourself, you don't start it, otherwise you do this. You have a function that takes in a server argument, right? And then you send request vote rpc, and if vote granted and vote count plus plus, now this should be atomic. Otherwise what's going to happen is this can have race condition, should to do should be atomic. Now if vote granted, if you did not get the vote, right, then if replies term is greater than your current term, then you become follower. Nothing else. Then this keeps happening. Okay, you either get the required vote for to become leader, or there are no pending votes. You want to wait till that time, right? So for now I'll just use this our wrapped peers lock here, and then we unlock it. If vote count is greater than, okay, we lock it, sorry, and we keep doing. If we have, then we send heartbeats also. Okay, let's try it now. Unlock of unlocked mutex. Someone else unlocked it or what? Maybe we use something else here instead of sync dot condition, even though that might not be uh, as good as we want, huh? Cool. We increment it here. Cool. If vote count not load, okay, and everyone started election and probably there's some deadlock. How do we wait to reach required votes or for all pending votes to be resolved? Not like this. Let's do this. It's very bad for CPU, but some progress. They were able to send votes before that, but yeah, there's some deadlock here. So okay, this is atomic now. Shouldn't solve anything though. So see, everyone started leader election go routine. First it was peer 0, then 2 started election, then 2, then 1, then 1 received RPC from 0 and 0 received from 1, and then 0 got a result. 2 received from 0, peer 2 did send it to anyone. See result. Okay, the person asking for vote, right? No, it's the peer request vote RPC result. Reply result to peer. Cool. So 0 sent to 1 and 1 sent to 2, that they cannot vote. Then 1 sent to 0, 0 sent to 2, and then they get stuck somewhere. Probably because of our critical sections. Right? Let's check. Request vote also requires this lock. And okay, what's up? What's going on? What is going on here? Am I live? Okay, I've been live since 22 hours. Okay. I'm not able to see it on my channel. Anyways, coming back to it, I'll just quickly check. Cool, we are live. I don't know why it's not working, but it's okay. Reset all zoom, right? It is there, so you can just do zoom in. Cool. Let's check our critical section. Okay, to start a leader election, you can't be starting a leader election and voting at the same time. You need to read the state within a lock, or it gets locked. Now once you read the state, you unlock and then send the vote. Now to send request vote, you don't need any locking. Once you have received the vote, and if it's a false, then you need to take a lock. When you take a lock, you are comparing with previous value of current term. You can't be doing that. Should be doing it with rf dot current term. Then reply dot term and state becomes follower. Then you unlock it. It's a very small section. It should not lock anyone. So everyone is doing this. Everyone is sending requests, and then this is also there till the time it is there, and you have to lock it once. And why do you do this? Because of this, right? Lock it, you unlock it, rf dot dot. Oh, good. So this this is funky in the lock implementation, but I guess this could have been the deadlock. We'll see. Maybe not. So we were not able to do leader election till now. Cool, cool, cool. Okay, okay. Pause for a random amount, and then there's no leader election, right? Everyone started it once, and they never restarted the election. Then why is that the case? In all the cases, you should be out here, right? uh, Waiting peer percentage 3, waiting for random time before starting next election, and the peer rf dot who are you, who are you, who are you, who are you? Huh. Me. Cool. Peer percentage starting next election, and there we go. Just keeps waiting, right? No one is starting next election, then we are not resetting some state probably, right? So you need to become follower first, and ticker. When do you reset it? Maybe this they say you didn't, but in this term you have already voted, right? When does the term change? When do we change the term? Because if I do this, I cannot do it in this current term. Because if I change, let's say, state in current term, it's not gonna work, right? If can start election, then only your term changes. I mean, that's one of the case when your term changes. You are not changing the states here. Let's read the paper. So uh, let's consider a scenario where three raft nodes all start at term 0, start election, and not get single vote as started leader election at same time. When do we reset their state? Two follower voted for request to nil, etc. I don't think we can change as soon as we know that it can't form majority slash become leader. This will violate the principle that a peer slash node can vote only once in a term. Sorry, I got cold. I didn't feel like going through the paper. You're exactly right. You're absolutely right. The servers don't immediately because deadlocked. If they clear they wait in the candidate set. When the servers realize they cannot get a majority, they take no immediate action. Instead, they randomized and first server times out and increments its term because election timeouts are randomized. One server will invalidate the timeout before the others. Server 1 times out. Upon timing out, server 1 starts a new election by incrementing its current term. Because its current term has increased, it is allowed to cast a new vote. It immediately sets voted for to itself and sends out a new round of request vote RPCs. The other servers discover the new term and reset. Any server receives a term strictly greater, it must immediately updates convert to a follower. Okay, in that case, we can't change anything here to do something here only, right? Okay. how do we know that? This heartbeat thing is fine. Already voted. If received heartbeat, just forget about it. Or you are a leader, forget about it. Already voted is where we need to do something. So you're not. You have to be a follower, right? So it there's been a long time since your last heartbeat, right? But if not state is equals to equal, if you are a candidate, right, then you will need to convert to a follower and voted for nil. Okay, little bit improvement. So when you do this, you still haven't incremented. You increment your term only when you can start an election, right? Slight improvement. We'll read some logs to understand what's going on, right? Alright, so waiting for random 0, 1, 2, then 1 started next election. Peer 2 received vote and did not grant a vote. Should have. Why did it not grant a vote? If args dot term is less than current term, voted for not nil. But if term has changed, huh? So if you got something with higher term in a single term, okay. Now in next phase, let's say year 1 starts election first. It will have term 1, others still at term 0. Uh, how can they vote as their voted for won't be nil as they are still in previous term? I think here it makes sense to, if the term is higher, we violate this because now it has voted in this new and higher term, right? Only thing is, when is there voted for is automatically reset to null, then we discover the new term. Run says, sorry. Any server receives an RPC containing it must immediately update current term to larger value, convert to a follower. Because the voted for variable specifically records the candidate that received a vote in current term. Okay. Yeah, that makes sense. What if term is equal? Okay, ideally what would you do when term is equal? You got some peers, same term, you already voted for, you don't. The situation differently. Logs for a vote. Candidate's log is at least as up to date. Okay, we have log here. Okay, so else if args dot term equals to this, then you get all this stuff, right? As we know term is higher, then rf dot current term would be as term follower and voted for this candidate. Reply and vote granted. Cool, this works. Now okay. So you update your voted for and you say vote granted. Your current term would become this, right? And you grant the vote. Now if terms are equal, then if you have already voted for, you don't do anything. If arg's last log term is less than your current term, or last log index is less than last applied, then return. Okay, this should show our single leader election. Not bad, not bad. Entries as type, append entries args. Append entries. Huh. Reply. Okay, what are we doing here? So we check our logs. If it is less than previous log index of whoever called append, or could equal be okay. I don't think this will pass, but let's see. Tell me this passes. This is a very hacky implementation. Expected one leader, test many elections. Not bad. So you're saying that re-election is also passing. Now I should remove this log. Keep heartbeats sending. Huh. Okay, our single election is working now, then re-election. What are we doing exactly in re-election? We have three servers. Okay, annotate test. Check one leader. If the leader disconnect renew, so ts dot z dot disconnect, then check one leader. Reasons that should not disturb the new leader, and the old leader should switch to follower. No quorum, new leader should be elected. Check that the one connected server does not think it's a leader. Quorum arises, it should elect a leader. Rejoin shouldn't prevent leader from existing. So did not become any leader, right? See request vote to Zier. Okay, okay. Hmm. So something to do with heartbeats now. Okay, 1 hour. Okay, let's take a look here at this implementation. Append entries. Argument would be term leader ID. Previous log index, previous log term, log entries to store leaders commit index. Cool. Then term for leader to update itself. True follower contained entry matching previous log index and previous log term. Yeah. How do we store logs properly? I don't really know. But let's see. So term would be your, okay, you take a log for building this because you're sending heartbeats. Can't be in logs, this would cause a deadlock. Last log term. So your current term append send heartbeats, you are the leader, and previous log index would be rf dot last applied. Then entries, log entries. You're not sending a log entry. Okay, should not be sending an entry actually. Then okay, we send the commit index, then append entries, you got a reply, right? Then what do we do with the reply? If not okay, then just stop. This function would automatically do this. No, which go version we could do w.go, but it's fine for now. We need to update next index and match index, right? So someone sent a heartbeat. peer 1 becomes the leader. So peer 0 becomes leader. Huh. Some fuck up happened. It is okay. When it's someone expected to where is append entries RPC? Huh. So this is the term. If rf.current term is less than args.term, you return. How do you know it's only leader can call append entries? RPC? I think so. So let's say PRD is anyone getting heartbeats? They got it once, and that's all. And current term would obviously be less than that. Let's just do it here. Okay, I don't know what this helps with, but it's okay. Huh. So now there is one leader, two followers. Till this time here we are good. After that, when should it send heartbeat again? Who's sending these heartbeats? Bro, can't be sending heartbeats from here. Hey, let's just keep trying to send heartbeats. Sorry. If okay, let's just do this. No, it has to be a for loop, right? So ticker heartbeat every 100 millisecond. Or select you get on this ticker channel. for ticker dot should use range instead of for select. Okay, for range cool. So every 100 second we have 100 millisecond we have heartbeats now. We have this for range over time dot tick. Tick is a convenience wrapper around ticking channel only. New ticker. Okay, new ticker returns a ticker containing a channel that will send time after each tick. The period of ticks is specified by duration. The ticker will adjust the time interval or drop ticks to make up for slow receivers. The duration must be greater than 0, otherwise it will panic, which is okay. For range over a channel, it is not at all working. Why is it not working? For range time dot tick times time dot second print tick. Build failed at all. Okay, count equals to 0, count plus if count is greater than 5, break. So it is giving us the tick. Oh shit. It's okay. Okay, so peer 0 2 0 2 0 2, they got it. So as long as they are getting these, see, we are good. So now we are able to send heartbeats. We are able to do this. Now in absence of a heartbeat, a leader election should start. We're probably missing something there. So if it is candidate, then state changes. Does it matter? All right. Now the last one is remaining. Many election. Oh my god, we done 3A? Don't tell me. A code is bad, but even if it works, this is great news. Yeah, it failed. Term 4 has 3 leaders. Whoa. Not good. Huh. Request RPC logs. I think you can remove those. This time it passed, so probably implementation is not right actually, if you think about it, right? If it's failing sometimes, passing sometimes. Let's run a couple of times at least. Okay, we'll for now consider it as passing. Lab 3A passing. Send milestone. Lab 3B's log, then persistence, and log compaction. Okay, we just finished a part of lab 3. Lab 3A leader election city code. Okay, we made some progress. I know, not what we wanted. feel good. I'm feeling good now. Made some progress after a couple of weeks of break. Could say break from studying, just so I could spend time on office sit. Okay, we have 44 commits. Uh, I started in November, but mainly started on May 24. Oh, literally 1 month break after lab 2. Cool. Should we focus on next lab or figure out? Let's go through hints. You can't easily run your raft into, okay, follow the papers figure 2. At this point you care about sending and receiving request vote RPCs, rules for servers that relay and state related. Add figure 2 state for leader election to raft struct. Fill in request vote args, reply structs, modify to create a background go routine that will kick off leader election periodically by sending out request vote RPCs. Another peer from a while. Implement heartbeats, define append entry though you may not need all the arguments yet. Have the leader send them write and append RPC. Tester requires the leader send heartbeats no more than 10 times per second. The tester requires your raft to elect a new leader within 5 seconds of the failure of old leader. Election timeouts in the range of 150. Such a range of leader sends heartbeat considerably more often than once. Because it's 10, you will have to use election timeout that's larger than paper. Okay, rand is useful. You'll need to write code that takes actions periodically or after. The easiest way, ticker go routine. Don't use ghost time.timer, which are difficult to use correctly. Oh, would I struggle passing the test? Read the paper tools figure again. Implement get state. Tester calls your kill method when it's permanently shutting down. You can check whether kill has been called. Whose name start with capital. Most selling maybe debugging. Spend some time. Okay, if you fail a test, the tester produces a file that visualizes guidance for debugging. Colors. Ha. Alright, for now it is okay. Let's run it once more. 3B passes. Okay, it failed this time. Term 2 has 2 leaders. Yeah, so there are some issues. Let's see. So test re-election Leader in term 4 is 2, leader in term 5 is 0, partition 2 and 0 1. Leader in term 5 is 0, unexpected leader found, partition, now it is 0 1 and 2. Okay, if a leader is not able to send heartbeats, does it step down? When we have three nodes all partitioned from each other, or 1/2 partition and leader is alone, does leader step down? It ideally should, otherwise it can reserve incorrect or wrong results, right? Keeps trying. Actually, timeout. The partition heals and the rest of the cluster has moved on to a higher term. Wrapped and for schedule. If a leader discovered any RPC request or response containing okay, so what happened here? Leader equals to 2 started peer 1 becomes leader, peer 2 becomes leader. It's actually correct, right? Peer 1 and 2 both become leader. How come? Let's keep running till we figure out the issue. initially only started leader election. That means da, 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 da. Okay, I'll be back. All right, let's see. So, peer 1 and 2 started leader election. 0 also started. Everyone granted vote false. Now peer 1 started again and peer 2 voted true. Peer 1 also, peer 1 becomes leader basically. Then peer 0 started election and peer 1 received request to vote RPC from peer 0 and it granted the vote. It should never have done that. RPC result. Reply dot term would be current term, right? D and asks, okay, 1, 2, 2 unexpected leader. Wow, that's some randomness. Do I need to restart? Okay, wait, changes. leader equals to 0. Zero becomes leader, then peer 1 did not get. Okay, let's check this one now. Cool. Peer 1 becomes leader, right? Peer 1 started election. Request vote RPC roast. Peer 2 said yes. Its term is 4. Peer 2 it says 3. Unexpected leader found. What does this even mean now? Does not think. One connected server does not think it is the leader. Leader is equals to 0. How come 0 is the leader? Huh? Peer 0 becomes leader here. Then peer 1 2 said. Peer 2 received append entries. Yeah. Now peer 2 received append entries from peer 0, right? Yep. Yeah, this should help us. I think we need to handle the result from append RPC. It is simple. It says, okay, I don't need you for now. Okay, so here's the thing. Peer 1 becomes leader here. Peer 0 was already a leader here. Then 1 and 2 were getting this from peer 0. Then there's some issue, so peer 1 becomes, peer 2 voted for it, then peer 1 became leader. Now peer 2 received append entries from peer 1, which is okay. Peer 0 also did that. Apparently peer 0 received append entries from peer 1, and peer 1 is at term 3, correct? That means, and it is at term 2, right? Received append entries. Yeah, we update hard here. If rf dot current term so if current term is less than args dot term, if rf dot state leader, then rf dot term would be rf dot state equals to follower dot name. Okay, can it fail now? I mean, it's okay if it fails. So if a leader gets if a leader is getting a law append entries call from someone, because let's say partition happened, uh, it is like this, that this case, right? When this partition happened, earlier 0 was leader, at this partition 1 become leader here, and its term increased. Now when its term increased, when 0 is available, it will send a request. 0 can also send, both are possible, so we need to handle that case also. Yeah, term 2 has 2 leaders. Ooh, that was fast actually. Let's see. So vote granted, peer 0 started, peer 1 started, peer 2 received from peer 1, and it said true to 1, right? Peer 2 request vote RPC result to peer 1. Then why would you start an election? That's another thing. Peer 1 received, peer 1 you have become a leader. Once you have granted a vote in current term, you cannot be allow another vote. Yeah, if it's a follower, this is going to be true. So if you are a follower, when you change the term, you can vote for yourself. But let's think of this case here. You voted for someone, you are a follower, you are yet to receive a heartbeat. So this is a race condition actually. how do you deal with it? Follower might have just voted, and it can and it might start election also. Double voting, bad, right? So we need to keep track when it last voted, or maybe last heartbeat. When you vote, you update your term, right? When your term has been updated. Okay, let's think of another case. 3 nodes. One node is bit early, starts election, gets vote from one more node, becomes leader. The node that voted for the leader also starts election, as it is a follower, and initial check is just that heartbeat last time, and state is follower. It is not good. Peer 1 received from peer 2 also. Peer 2 got from peer 1. Peer 2 received request vote RPC from peer 1. We need to somehow save this state. Someone is reading it and sending API calls, which is okay, but peer 1 is becoming leader. Peer 2 voted for peer 1 term 0. Then peer 1 request vote RPC to peer 2. Received peer 2 received vote from peer 1. Peer 1 received from 2 with term 2. then it has to grant it. Wait a minute. So it was just stuck here because it got it. Now it just increments the term, right? Request vote RPC is also heartbeat क्या? Check is only based on last heartbeat is slightly right and was follower only transitions to a candidate if its election timeout elapses without receiving a heartbeat or without granting a vote. It resets the timer. Hmm. Voted for. How do I voted for? So let's say we add a check on voted for, okay? Because if you have effectively become a follower, if I add who is responsible for resetting, who is responsible for resetting here? Who will be resetting the election timer? This is basically the election timer, right? Mm-hmm. Okay. This line of code I have race condition, I think basically on initial boot of nodes, if one node gets vote and the node giving vote can also increase term and get vote from the node that just got vote. We can't rely on heartbeat, right? uh, the node that got the vote first might not have sent heartbeat yet. Changes when node grants a vote. What field gets updated that you could use instead of or in addition to last heartbeat election and shouldn't start one myself. I recently participated in an election, so I might update. So I update voted for. You're saying that I can use voted for also if I say add a condition on voted for not equals to nil, then when do we reset it? No, we can reset it. Set the term now over. Do we reset state after election timer after line 404? I voted and I should wait versus I voted, enough time has passed and now a new election is needed. I voted and I should wait versus I voted, enough time has passed. Should start a new current terms election is truly stuck. When do I change the term? If I voted for someone and they become a leader, I should not be changing term or resetting voted for. If I do it the end of election timer, then this might not true, I think. It's the new term. So leader sends heartbeat thing append RPC. They send me a new slash updated term. Okay, how does that help? Let's see. On seeing heartbeat, I can update when I got heartbeat and skip section, go to till next timeout, and this continues. This still doesn't solve the case. Have voted have just voted on boot. Is other node sent request vote RPC, or we got the login ticker. My term becomes 1. Voted for, let's say, other. After request vote RPC call, clock release, get lock in ticker. Here what I do is at this point I am yet to receive heartbeat, as other node might not fully become leader, or they or append RPC might be for ticker lock release. Now I just increment term to 2 as current is 1, and other will vote for me. And vote. What if you also update last heartbeat at? Is that what Rapt recommends? Tools for servers for followers. Noted for doesn't really say anything though, but I can. I did think of it, but I'm not sure if Raft recommends doing this. This works, at least as per these test cases. Okay, this is working. Let's see. Make the change. Are passing now. Check if what I did is correct edge first spec or not. And the code. Okay, but this is still failing. Let's see. Peer 1 started election, then it became leader. Peer 2 voted for it. Okay, peer 1 start election, peer 1 become leader. Now peer 2 received append entries also. Term 3. Even if peer 2 started election, it is not the leader. There is actually no leader. Rap test 0 is the leader. Is failing because 0 is leader. Think like this. So here was in heartbeats. This was last heartbeat. Probably nothing after this. So one started election and became leader. Since partition, it still thinks of self as leader. Test partitions peer 0 peer 1 that's correct, but the test is checking the peer 0 but your get state still returns peer 0 as leader. uh, Peer 0 can only find it's not leader when either it sends heartbeat append RPC to others and get higher term, or new leader sends append RPC with higher term. That has not happened here. Can see okay. Server in follower leaders send periodic heartbeats to all in order to if a follower receives no communication election timeout. Follower increments its current, then votes for itself. Candidate continues to win election, means committed the log entry this period of time and the leaders. Does a leader step down? It can't reach to followers heart rates. Okay, I think I'll have to read this one. Think it's time to end today's stream. Yeah, 2 hours is enough.